Hello, chemistry scholars. Okay, welcome. This is the second video on ionic bonding. Please go back and watch the first video if you missed it. Okay, so this is ionic bonding number 2, and we want to start off with a joke. Okay, what do you do with a dead chemist? Barium. I know, isn't it great? All right, so a little review. Super quick review. Okay, remember that the valence electrons, they are associated with your group number. So this first group here, group number 1, all of them will have 1 valence electron. 2, 3 valence, 4, 5, 6, 7, 8 valence electrons. Okay, just a quick review because we need to make sure we know that. All right, so from last video, I assigned these as homework, so I hope that you have all of them written out, and I hope that you have them completed. So now is our opportunity to check our homework. If you weren't able to see the last video, please go back and watch video 1, because these are the ones that you should have completed for homework. So we're gonna walk through these together so that you can check your work. Okay, so the first thing is we have aluminum. Okay, aluminum reacts with nitrogen. So we have to decide which is a metal and which is a non-metal. Just for a quick review, we'll go back to here. Remember, metals are on the left side of the periodic table. So that's all of these yellow ones here. Those are also going to be metals. And then remember the green ones, these are metalloids. They have properties of metals and non-metals. And then we have all the ones over here, which are non-metals. Okay, so what that means is aluminum is going to be a metal, okay, and it has 3 valence electrons. And our other element was nitrogen. Okay, so nitrogen, that's going to be a non-metal, and it has 5 valence electrons. So, so now we're going to go ahead and label our. So we're going to go ahead and put aluminum here as our metal. So hopefully that's what you had for your homework. So we have aluminum there. And then we have nitrogen. Okay. And then as we said before, now we remember what the valence electrons were. We said that aluminum has 3 valence electrons. So we have 1, 2, 3 valence electrons for aluminum. And then for nitrogen, we have 5. So we're going to start at the top here. So 1, 2, 3, 4. And then now we're going to start pairing up. Okay. Now, so we have, so I have 3 electrons here, and it looks like nitrogen needs 3 electrons. Okay, so to do that, we're going to show our transferring. So we're going to change our transfer. I'm going to change the pen ink here to blue so we can see the transfer. Okay, so we're going to transfer this in here. Put an arrow. And then we have an X here. Okay, we're going to transfer this in. Remember, we're transferring in next to the single electrons. Okay, so all the single ladies, they all want to get together and go out dancing. Okay, so that's how we pair up all the single ladies. All right, so now I'm going to put this last one, my last pair. This one needs to be here. Okay, I'm going to put my X here. Okay, that's supposed to be an arrow. All right, now, okay, so I'm finished with my step 1. Step 2 is brackets and charges. Okay, so aluminum, it lost all of these electrons. So if it loses all of these electrons, okay, that means there's no dots anymore around aluminum. So check your homework, make sure you didn't put any dots around that. That's a very common mistake. Okay, erase them if you did. All right, so now if it loses 3 electrons, okay, it's going to become more positive. Okay, so now I'm going to put a +3 here. Okay, so that's going to be a +3. And we're going to go ahead and we're going to move on to the nitrogen. So nitrogen, I have to show everything that's around the nitrogen. Okay, so I have my original 5 electrons. Oops. Remember, it has to look exactly the same as the other one. So I want you to pick out my mistake. Try to figure out what I did wrong. Okay, figure out what I did wrong. So what I did wrong was, this one right here, that should be a blue X because that got transferred in from the aluminum. Okay, so we're going to go ahead and erase that. Okay, so now we have to represent the electrons that got transferred in. Okay, so now I'm going to have an X here, X here, and an X here. Okay, now, am I finished? Let me see. Okay, I think that I'm done. So I think that I'm done. So now I'm going to look at the formula. So I have 1 aluminum reacting with 1 nitrogen. So that means I have a 1-to-1 ratio. So I have 1-to-1 ratio. Okay, and next video, we're going to start to break out and we're going to not have a 1-to-1 ratio anymore, okay? So that's why it's important to think about the ratio. So now I have aluminum. So I'm just going to put my my chemical formula. Okay, so it's ALN. I'm working on my writing. Thank you guys for bearing with me through this process. I'm learning to write with this new fun pen. All right, so now I'm going to balance my charges. Oh, and I look up here, I have a +3. Oh, this is why I really want to balance my charges. This is going to help me check my work. So now I can find out what I did wrong. I found out that, oh, I didn't put my charge on my nitrogen. That's why it's really important to do all the steps. All right, so now I'm going to put my charge on my nitrogen. It gained 1, 2, 3 electrons. So electrons are negative, so that's going to become even more negative. So that means I'm going to have a -3 charge. All right, now I can balance my charges. Okay, so I have a +3. I have a -3. Okay, and perfect. It is a balanced compound. Okay, we want it to equal 0. Perfect. So I hope this is exactly what you had on your homework. Let's go ahead and move on to the next one. All right, so we have barium and sulfur. Okay, so we'll go back and we're going to look at our periodic table. So we have barium. So barium is Ba, it's right here. So it has 2 valence electrons and that's our metal. And we have sulfur. Sulfur is right here. It's going to be our non-metal and it has 6 valence electrons. All right, so my metal was barium. And my non-metal is sulfur. Okay, that one looks a little rough. We're gonna, we will rewrite that so it looks like an S. Okay, so that one's going to be sulfur. And like we said with barium, barium has 2 valence electrons. So I'm going to go ahead and write those in. Okay, and sulfur has 6 valence electrons. So I'm always going to start at the top. 3, 4, 5, and 6. Okay, this leaves 2 spots for these 2 electrons to transfer in. All right, so now we're going to show the transferring of the 2 electrons with our arrows and X's. So we'll transfer these in. X here. Transfer this in. Remember, they're transferring in right next to all the singles. All the single ladies want to add up. All the single ladies. All the single ladies. So feel free to do the little dance every time you do the single ladies because that makes it more fun. All right, so that is perfect. All right, now we're going to do our brackets. Now remember, barium, it lost all of those electrons, so I'm not putting any more dots around barium. It lost 2 electrons, so that means when you lose electrons, you're going to become more positive because you have 2 more protons than you do electrons because it's not a neutral atom anymore. So I'm going to put a plus charge. So we have plus 2. Okay, and now we have our sulfur. Okay, so we're going to put in all of the electrons. Everything you see around here, that's what you're going to have around the sulfur. Okay, so I have to indicate all of these. So 1, 2. Okay, so we're going to erase this one because we need to make sure we have okay, so we got to make sure we put our blue X's where they belong. So don't worry if you make mistakes. It's great to make mistakes. That's how you learn, okay? So it's great to make mistakes. That way you can erase. Also, make sure you're using a pencil so it's easy to erase. All right, so now we're going to put in our blue X's that transferred over. Okay. Then the last thing is we're going to set our charges. So I had 2 electrons transfer in. So when electrons come in, electrons are more negative. So that means I'm going to have a negative charge. So we're going to have a -2 charge here. And now my formula, once again, is a 1-to-1 ratio. So that means I have 1 barium for 1 sulfur. So BAS, okay, is going to be our chemical formula. And we have to balance our charges. So I have a +1. Oh, I have a +2. Okay, +2, and then -2 is going to give me a 0. All right, great. So the next 2, I'm just going to show you the answer so that way you can check them on your own. Okay, so I'm just going to show you the answers on those, so that's going to make it a little bit easier. Okay, so now let's go look at the next 2 problems. So now what we have is, so this one's already worked out for us. So we have cesium is our metal, and we have our non-metal is iodine. Cesium has 1 valence electron that is going to get transferred okay, to the nonmetal, which is iodine. Iodine had 7 valence electrons. So cesium gets a +1 charge because it lost 1 electron, okay? And the iodine, it's going to get a -1 charge because it gained that 1 electron. Make sure you have all of these valence electrons. So 1, 2, 3, 4, 5, 6, 7, and then your 8, which completes its octet rule. All right, our formula is a 1-to-1. So our formula is going to be CSI. And now we're going to balance the charges. So we have a +1 -1 is going to give us 0. So this compound is very stable and happy. All right, so ionic bonding using Lewis dot structures. So we have our beryllium, that's going to be our metal. We have oxygen, which is our non-metal. We have beryllium had 2 valence electrons that it wanted to give up to oxygen so oxygen can complete its octet rule. Okay, so we have these 2 transferred in. So as a question I want you to answer is, what holds this ionic bond together? Okay, think about that. We learned that last video. What holds this ionic bond together? So beryllium gets a +2 charge because it lost 2 electrons. Oxygen gets a -2 charge because it gained 2 electrons to complete its octet rule. We have a 1-to-1 formula, and our formula is going to be BeO. That's going to be our chemical formula for this compound. Beryllium oxide, we will get into naming in a couple more videos. We have balanced the charges, so I have a +2, -2, and it's going to equal 0. This really helps us check our work. So if you remembered right, what keeps the ionic bond together is going to be the opposite charges. So this is a positive charge and this is a negative charge. Those opposite charges, they are going to attract and keep the beryllium bonded to the oxygen. Okay, that is all for today. I hope you guys did really well on your homework. Tomorrow we are going to get into elements, or on the next video, we're going to get into elements that have a formula where there will be 2 elements bonding to 1 element. Okay, so we're going to get into that when we have a ratio that's not a 1-to-1 tomorrow. All right, great job. I hope you enjoyed the video.